Hello, this is Eric. Can you see me here? Yeah, this is running OpenCV on ESP32. It's working as a standalone and handling everything on ESP32. With the image obtained from the camera, it's doing canny edge detection with OpenCV library in real time. This is very interesting. OpenCV is built to work on many platforms, but working on standalone on ESP32 is really cool. In fact, it does not include a full version of OpenCV, but works with a shrunken version of OpenCV. I don't know what projects you are trying to do, but I think many applications are possible with this. This is enough for me. In this video, I will show you how I configure my build environment to use it. If you can build the shrink the OpenCV for ESP32 without any problems, then this video is not for you. Please find more interesting projects on my channel. All you need to make this work is memory. It needs more memory than normal work. In addition to containing the OpenCV library, it requires a heap space for image processing. The device used here is TTGO camera plus model and includes ESP32-T0WDQ6. It has 520 kilobytes of SRAM, 8 megabytes of PSRAM, and 4 megabytes of flash memory. Please check yours first. So let's get started. The first thing to check is ESP-IDF is installed on your system. I'm working on ESP-IDF based project using Visual Studio Code. A long time ago, I uploaded a video of installing ESP-IDF on Mac, but it's been a while. You can easily configure the environment by following the instructions provided by official site. If you need to install it, this method is highly recommended. So I believe ESP-IDF is ready. To make sure everything's fine, let's open the Hello World example and try to build it. When the project opens, a pop-up will appear asking you to select compiler. I usually choose GCC 8.4.0 extends ESP32. Okay, I won't touch anything, just select the port which is connected to my device. And then just select build flash and start a monitor on your device. This is the magic key. Again, this is for testing using ESP-IDF. If you can do it, you need to stop this video here and set it up again. Uploaded to my device successfully. You can see not only the build information but also device information there. Okay, all looks good. Let's move on. It's time to meet today's star. This is a GitHub repository where all recipes are prepared to run OpenCV on ESP32. You can make basic preparations for the OpenCV project with this person's output. He did a great job. This is today's goal, building the same code on the same device and having the same result. It wasn't as easy as I thought. There were a lot of issues. Anyway, let's make a shot. The first thing to do is bring this repository to your local environment. You can clone it to any folder you want. After that, I will open the Hello OpenCV example from a VS Code. You can see a total of 3 examples here. I'm gonna select Hello OpenCV to simply check if the OpenCV library works properly. And then I will try the TTGO demo, which is my goal for this project. Each demo includes all the pre-built OpenCV libraries. If the build works normally without any changes, you can start the project very easily. As before, select the compiler and move on. This is the main CPP file of Hello OpenCV. We have nothing to touch here. It's just check whether the pre-built OpenCV is working fine or not. Let me build and flash it at once. It takes time to build, but I made this part pretty quickly. You got it right? The build is successful and it's running on my connected device. Great. The math object used in OpenCV is normally created and printed. This confirms the basic OpenCV library works fine. Now let me open my target project, the TTGO demo. If this builds successfully, all preparations for starting a new project are finished. As before, select the compiler and move on. This time without modifying anything too, I just build and then flash. Let's see how it goes. Oh man, this time the error occurs. It says undefined reference to sysconfig. As I recall, this should be reference to return the number of threads available on ESP32. Unfortunately, I have spent a lot of time trying to solve this, but I haven't gotten a perfect solution yet. Before visiting the GitHub page again, let me clean up the project. This is to clear the current failed build. There was an issue report for this, and luckily I was able to find a workaround there. Seems like if you work on Linux, you can work with the pre-built OpenCV library he made without any problems. And if you have other problems other than this, it's also recommended to follow this workaround. This author has shown a way of using Docker image. This creates the same environment he built. So using this, we can get the same result because we are building it in the same environment. Let me check if I have Docker. Oops, I don't have it. Actually, I deleted it just in advance to show you from the scratch. Please download it from the Docker site or install it using Brew. This time I'll get it for desktop app. In fact, all we need is Docker's CLI. Anyway, let's install it. Let's move fast. It's just downloading and installing. There are really good articles about Docker and containers, so you can find more detailed information through Googling. Docker installation is complete. Now let's run Docker in the terminal again. This time, the Docker command works fine. Let's pull the Docker image he mentioned, just copy and paste it. Oh, I don't need the $sign though. Pulling is done, all looks good. Now go to the ESP32 OpenCV folder and run the Docker image. If I don't attach the release version to the last part, the current latest version of the Docker image is newly downloaded again, so I have to use it this way. Now I'm inside the Docker image. Here it has been activated with the root account. All you have to do is to build OpenCV. All scripts were ready to go. With this, the OpenCV library in the TTGO demo will be newly built. Okay, seems like the new library is ready. Let me check if there are any changes. Go back to VS Code and 1 second. See, there are changes in the OpenCV folder. I'm pretty sure we are on the right track. Finally, it's time to build the project. Let's build this project with the new library. I have to succeed this time. Again, running ESP-IDF by Docker is Linux-based version 4.2. My VS Code ESP-IDF is currently the latest version 4.4.1. So because Docker's ESP-IDF has to be used to build for this project, currently it's working in the console. Project build complete. Yes, finally it works. The rest of the task is to flash the built project to the device. You can do it with this command, but I will use my VS Code. Here you can see the newly built OpenCV library. Because this project has already been built, I just do a flash. It's being uploaded to the device without any problems. All done. Let's see how this TTGO demo works. It's using LVGL for the GUI. A screen called TTGO demo is displayed first. After that, every 30 seconds, RGB mode, Grayscale mode, Binarized mode, and Etch mode are executed repeatedly. The camera resolution used here is 240 by 240, which is the built-in screen size. On the left, you can see the FPS of each state. Can Etch detection is showing the lowest FPS as it requires the most computation. It makes sense. Other than that, it's calculated to be about 6 FPS on average. The performance isn't great, but considering the computing power of ESP32, I think it's pretty good. I'm really looking forward to the next project with this. Thank you for watching. See you on the next project.